So how do we insert blocks in Simulink? So there are two ways. The first method is go to library browser. If you go to your library browser, you have the Simulink library. Under the Simulink library, you have other sub-libraries where you can obtain your blocks. So for this model, we can find our transfer function model from the continuous library. So we have the transfer function block. So if you go to sources, say I want to work with a step input. So I have my step input here. And finally, in order to visualize my output, I can use the sinks library, and then I will make use of scope. So the second method for inserting blocks is you can just double click on your screen and then type the name of the block you want to insert. So if I double click, I can just tap on transfer function, and you can see I have my transfer function option here. So if I click on it, it will insert the block. So you can delete a block if you don't want to use it. Just right click and then click on cut. And if you don't want to use a block but you don't want to delete it, you can just highlight it and then comment out. So by commenting out, it is still there, but whenever you run your model, it will not be considered. So I want to use the scope, so I will uncomment it. Say I want to change the names, I can just change the name, say to input. And if you want to change the font, you can go to format, then change the font, for example to 20, just to make it bigger. This is my plant, I can change it to my plant or my model. Let me just give it plant, and then so this is just my visualizer. I want to use it for my analysis. So that is, you can increase the size of your font. So for the transfer function, by default it is 1 over s plus 1. However, I want to change it to the transfer function I want to work with. So all you need is to double click on the block. Whichever block you want to edit, you just have to double click on it. So if I double click on it, so for the numerator coefficient, I can change it to 1, 1, because my numerator is just s plus 1. And for the denominator coefficient, I can change it to 1, 5, 2. So I just click on apply. Okay. So expanding it allows me to see what I inserted. So now I just want to connect them. So you can connect and then connect them by dragging from one block to another. So another important thing is you can name the signals in your Simulink block diagram. So say this one is a signal, that is the input signal going into the plant, and this one is the output signal. So say I want to give it a name input, and for my output I can do the same, just double click on the signal and give it the name output. I have my block diagram set for visualization. I can just run. So this is the stop time. You can change it to the time you want to do your simulation. So it is by default at 10. So if I run the signal, you double click on it, and here is your visualizer. By default, the scope can take only one signal, but you can actually change the number of signals it can take by going into its configuration, which is here, and then change the number of input ports. So for example, if I want to also see the input, so it will be 2. If you want to visualize 5 signals, you can just change it to 5. So for now, we'll keep it in at 2. So by doing so, you'll see I have two ports. I will just change the output signal from the first port to the second port. So from here to here, and then I will have my input signal taken from here. So if you want to take it, you just press on Control and hold it, then drag it to the second or the first port. So now my visualizer can visualize both the input as well as the output signal. So if I click on run, so I have my visualizer. As you can see, you have two signals, one in yellow and one in blue. So if you want to see the names or which one is input, which one is output, since I already named the signals already, I can just go to view and then click on legend. So you can see I have my input is in yellow and my output is in blue. So another method for visualizing your signals, this time inline, is using the dashboard scope. So you can double click and write dashboard scope. So dashboard, so you have your dashboard scope here. So it is here. Let me bring it here. So by double clicking on the dashboard scope, you can specify the signals you want to view inline. So if I double click, I can just click on my input because I want to see my input. So I will select it, and then I will click on my output because I also want to see my output. So I click on apply, then OK. So you can then click on run. You have your input as well as your output, and you have your legend here. So it is the same signal with the one from scope. So the only difference is this one is inline, but for this one you have to click on scope in order to see it. So the third method for visualizing your signal is by logging the signal and then using the data inspector. So if you want to log any signal, you just go to the signal, you right click and then log selected signal. So I want to log my input, I will also log my output. So I also log my output. So now if I run my Simulink model, and then if I go to data inspector, which is in simulation tab, I will be able to visualize my signal. So they are here since I already logged them. If you select on input, you'll be able to see the input here in blue, and if you select the output, you'll be able to see your output here. So you can actually edit your plot from here. So another thing with the Simulink data inspector is you can export your data to Excel or to MATLAB workspace for analysis. Different options here, either to Excel or to MATLAB. So say I want to export it just to MATLAB, I just click on export. So now if you go to your MATLAB workspace, you'll be able to see the data. So the second method in which you can export your data to MATLAB workspace is by using the to workspace block. So if I just click on to workspace, so you have the to workspace here, and I can export my inputs. I can also export my outputs. So you can give it like different names. So for example, if I want to export this as input, you can also select the save format. There are different types, but I prefer to work with structure with time. So you can apply and then OK. For the output also, I can change the name. For output, I'll change the save format to structure with time. Okay, so if you run, I will expect my data to be in MATLAB. So this is the data I exported from Simulink. So you can see I have my input as well as output. So you can actually use it to do your analysis in MATLAB. If still I have my scope as a scope that has one input, I can still visualize my signal from the scope but with the aid of a multiplexer. So what I will do is I will just extract my mouse block, so it actually merges signals. It by default it takes two signals, but you can double click and change the number of signals it can take. So I know that I want to give it my output as well as my input. So it means the output of the multiplexer has both the input as well as the output. So I'll just take this one to my scope, and by running I will be able to see my two signals. So this is just an open loop control where the input is independent on the output, and as such it will be difficult for me to achieve a desired output. So say I want to achieve an output of 1, so as you can see it is settling at around 0.5. I can actually change my final value, my step value, for example to 1.5, and then observe. So as you can see it is still not up to 1. So for example if I change it to 2, it is now actually approaching 1, but the performance of the response may not be desirable. So in order to achieve a desired performance as well as a desired tracking, I can make use of feedback control. So for feedback control, I will need a controller that will take the difference between the reference output as well as the actual output of the system, and then use that difference to compute an input that will drive the plan such that the desired output is equal to the actual output. So let us see how we can do that. So let me just remove this. So this will now be my reference. This will be my reference. I will need a controller. Let me use a PID controller. So I have my PID controller here. So as I said, I need the difference between the output and input. So in order to add or subtract signals, you can use the add block or the sum block. So let me use the sum block. So here is my sum block. So this one it's doing like addition, because we have like plus signs, so you can change the sign. So I change the last positive sign to negatives. So I just have to drag my signal here to here, and then my output I will take it from here to here. So this one is now my reference. So I have my reference now, and I still have my output. Now I still need to take this to my visualizer. So for PID controller, actually it has three gains: the proportional gain, the integral gain, and the derivative gain. So both the proportional and integral, they tend to increase the speed of your response as well as reduce the steady state error of your tracking, while the derivative gain tends to regulate the rate at which the error is removed from the system. So by default, as you can see, the derivative gain is set to 0, while the proportional and integral are set to 1. So now if I click on my run, so as you can see now I have my reference in blue and my actual output in red. So although it is like stabilizing at 1, but you can see the response is slow. So you can adjust your gains in order to make the response better. So for example, if I change this one, for example, to 4, the integral gain to 4, and then click on run again, so you can see now it is like a bit fast and it tracks the reference signal, but there is an overshoot. So you can do like using try and error method until you obtain a satisfactory performance. Alternatively, you can automatically tune your PID controller by double clicking on the PID block and then click on tune. So that will open the PID tuner platform, which will enable to tune your system. So as you can see, the straight line is just the tune response, while the dash line is the block response. So this one is the actual response, and this one is the tuned. So the straight line is just the tune response, and you can adjust the performance using these sliders. So if I want to, for example, increase the response time, so you can see it becomes faster, but the overshoot is actually increasing. So if you obtain a performance that you think is satisfactory, you just click on update block, and the parameters here will be updated in your PID controller block. We then click on close, and you can see my PID block is updated with the new gains. So I can just make this one is approximately 0. I can apply, then okay. So if I run, so you can see the performance is updated based on the PID gains I obtained from my tuning. Watch the video on the screen if you want to learn how to develop a model of a spring damper system in Simulink. Thank you.